No, the directions for number 12 and 13 are to find all the zeros, state the multiplicities, and the behavior at the x-axis. So let's go through it. For 2x squared, it's 2 times what gives you 0, and that's 0. And so that's 0 with a multiplicity of 2, which means we're going to bounce at 0. So at 0, I have 0, and I'm going to bounce. For this one, I've got x plus 2 to the 4th power. That means the 0 is negative 2 with a multiplicity of 4. That's an even multiplicity, which means we're going to bounce at negative 2. So I'm going to go over here, I'm going to label this as negative 2. Should label that as 0. And I'm going to bounce again. The next one is x plus 5, so that's a root of negative 5. There's no power on there like visible, so it's an understood 1, which means cross straight through at negative 5. So I'm going to go over here to negative 5. And we're going to cross straight through. And the last root is, I got to set this equal to 0. If you set 3x minus 8 equal to 0, you would add the 8 and divide by 3, or think reverse bottoms up, and the opposite of negative 8/3 is positive 8/3. So positive 8/3, and it has a power of 3, so multiplicity of 3 means cross with a wave. Okay, so positive 8/3 is 2 2/3, so just okay. And I'm going to cross with a wave. So the only other piece of information I need to know is, where do I start? Do I start from above or start from below? And for that I need my degree and the sign of my leading coefficient. So the degree, just remember that in order to find the degree, you add up all the multiplicities. So I've got 2 plus 4, which is 6, plus 1 is 7, plus 3 is 10. And remember, if I were to multiply all of these out, it would be multiplying 2x's by 4 terms of the next, and then another term, and then 3 more terms of the next. So, in fact, the highest power would be 10, which is even, which means we have 2 options. It's either up, up, or it's down, down. Yeah? And then we've got to determine the sign of the leading coefficient. If you just look out in the front, and all these x's are positive, that's a positive, so we're just going to go with positive. Which means that it has to be up, up. So I know I start from above and end above. Or start from above and end up. Okay. I'm going to kind of plan it out. I need to start from up here. I need to cross. I need to bounce. I need to bounce again. And then I need to cross the wave. So I'm going to come down here, cross straight through, come up and bounce. And I'm going to bounce again. Just kind of weird, but whatever. And then I need to cross the wave. So I'm going to come down, come up, and make sure that you approach it like you're approaching a maximum and leave it like you're leaving a minimum. And that is some approximation of the shape of this function. Okay, number 13. The first root is, well, see, there's a negative 3 out front, but there's no variable, so there's not a root there. The first root is going to be 1/2, so add the 1, divide by 2, or move the 2 down. So 1/2 is my first root with a multiplicity of 3, which means cross with a wave. So 1/2 cross with a wave. The next one is, right here we've got 4 with a multiplicity of 1, which means cross straight through. So I'm going to go here and label that as 4, cross straight through. The next one is negative 3 with a multiplicity of 6, and that's an even, so that means a bounce. So at negative 3 we're going to bounce. And the last one is going to be negative 8 with a multiplicity of 1, which means cross straight through. So negative 8, just cross straight through. Alright. Degree. So degree is adding up all the multiplicities or multiplying them out. So 3, multiplying out all these factors. 3, 4, 3 plus 1, plus 6 is 10, plus 1 is 11. So that's an odd degree, which means I have 2 options. Down, up, or up, down. Because odds go in opposite directions, right? And the leading coefficient, if you see out front, we've got this negative 3. Otherwise, all the x's are positive, so that would be a negative leading coefficient, which means we are, in general, starting from above and ending below. So starting from above and ending below. Starting from above, ending below. Okay, so I'm going to come from above, and I'm going to cross straight through. I have to come back up and balance. And then I have to cross with a wave, so I'm going to come through and just do like this and do cross with a wave means approach it like a max, leave it like a min. And then I'm going to have to cross straight through. So come back down and do that. And that is an approximation of the shape of this function. All right, number 14. We want to put these, write a polynomial function in standard form that contains the given roots. So this right here, I've got 3 plus 5i. So the factored form would be x minus 3 minus 5i. And so if I've got 3 plus 5i, I've also got 3 minus 5i. So I'm going to put x also minus 3 because the 3 is positive both times. But now I'm going to put plus 5i. All right. For this one, I've got x. If I've got 1 square root, I've got 2 square roots. I've got plus and minus the square root of 2. So I'm going to say minus the square root of 2 and then plus the square root of 2. So the degree of this polynomial will be 4. Let's multiply them out. We've got x squared minus 3x plus 5xi minus, change colors, minus 3x plus 9 minus 15i minus 5xi plus 15i. 5i, a negative 5i times a positive 5i is a negative 25i squared, which is a positive 25, which means this combines to x squared minus 6x plus 34. Okay, so now we're going to multiply these two out. X times x is x squared, square root of 2x, negative square root of 2x, and negative 2. Square root of 2 times square root of 2 is 2. So that simplifies down to just x squared minus 2. Now I'm going to distribute these. I'm going to kind of work it backwards though. I like to put the smaller one first, so that I'm only distributing 2 things instead of 3. I don't know, same thing. So x squared times x squared is x to the 4th. X squared times negative 6x is negative 6x cubed. X squared times 34 is a positive 34x squared. Then I'm going to distribute the negative 2, so negative 2x squared plus 12x and minus 68. Final answer, x to the 4th. We've got a function, so I'm going to put f of x equals x to the 4th minus 6x cubed plus 32x squared plus 12x minus 68. And barring any errors, which I definitely could have made, that's the answer. All right, number 15. Number 15, you've got 1, 2, 3, 4, 5, 6 roots. So I've got negative 1/2, which you could put x plus 1/2, but that wouldn't be a polynomial form. So you need to bottoms out. So that's 2x plus 1 times 2x plus 1. The square root of 5, we've got x plus the square root of 5, and we've got x minus the square root of 5. They come in conjugate pairs. And then the 4i, we've got x plus 4i, and we've got x minus 4i. So I'm going to multiply them out individually. This is 4x squared plus 2x is plus 4x, and then plus 1 is 1. So that's the first one. X times x is x squared. This term and this term will automatically, they will simplify each other out, so I'm not going to bother. And then that times that. Square root of 5 times negative square root of 5 is negative square root of 5 squared or negative 5. And that's weird. This times x is x squared. The middle two terms are going to cancel each other out because they're conjugate pairs. And positive 4i times negative 4i is negative 16i squared, which is positive 16. Okay, now we're going to distribute some more. I'm going to distribute these two first. That's x to the fourth. That's plus 16x squared minus 5x squared, so that's plus 11x squared. And then that is 50 and 30, so minus 80 times the 4x squared plus 4x plus 1. So let's distribute these. That's 4x to the 6th plus 44x to the 4th. I'm going to have an x to the 5th, so I'm just going to go ahead and kind of leave myself some space. So that's for x to the 5th, x to the 4th, so plus 44x to the 4th, and then minus 80x squared. Distribute the negative 4, or the 4x, I mean. 4x times x to the 4th is 4x to the 5th, plus 44x cubed, and then minus 320x. And then we're going to distribute the 1. So 1 times x to the 4th is x to the 4th. Plus that. 1 times 11x squared is 11x squared. And 1 times negative 80 is negative 80. So my final answer is f of x equals 4x to the 6th plus 4x to the 5th plus 45x to the 4th plus 44x cubed minus 69x squared minus 320x minus 80. Am I likely to put one like that on the test? No, because it's way too long and a waste of time. But this process was to help you remember how to multiply these out if you needed them. Okay, 2 more. Number 16. Identify the real zeros of the function and state their multiplicities. Assume that all zeros are halves or whole numbers. Okay, halves or whole numbers means that this right here looks like negative 3 with a multiplicity of 2. And this right here looks like 1/2 with a multiplicity of 1 because it crosses straight through. It says state the degree and the sign of the leading coefficient. So first off, let's go leading coefficient. This is starting down and ending up. So I know that this is in general going up from left to right, which means the sign of the leading coefficient is positive. It also says in order to determine the degree, you should know that 2i is also a root. Well, if 2i is a root, then so is negative 2i, which means as far as like determining my degree, I have 2 roots right here, 1 root right here, and then I have 2 more. So I have 2, 3, 4, 5 roots, which means my degree is 5. So if I want to write the function in factored form, then I would say f of x equals. For negative 3, I'm going to put x plus 3. It's a multiplicity of 2, so 2. For 1/2, you could put x minus 1/2, but you got to remember to bring the 2 up, so 2x minus 1. Multiplicity 1, so I'm just going to write that. And then x minus 2i and x plus 2i. And from here, it's just a matter of expanding that for standard form. Now, I will say, no, never mind. Okay. You know what? Scratch that. I don't need it. I'm not worried about it. Don't worry about it. Okay. Number 17. All right. Identify the real zeros of the function and state the multiplicities. Assume that all zeros are halves or whole numbers. So this right here, if that's negative 1, yeah? If that's negative 1, then that looks like 1/2, negative 1/2, but it looks like it crosses with a wave, so I'm going to go ahead and say negative 1/2 with a multiplicity of 3. This right here is positive 2 with a multiplicity of 1 because it crosses straight through, and then right here I'm thinking 3 with a multiplicity of 2 because it bounces. It says state the degree and the sign of the leading coefficient. So as far as leading coefficient goes, both are pointing down, which means it is an even degree. But since they're both pointing down, that's definitely a negative leading coefficient. Okay. It says you should know that -3 plus 2i root 5 is also a root. That's quite the root. -3 plus, and I usually write 2 square root of 5i, which means -3 minus 2 square root of 5i is also a root, which means in fact I have 3, 4, 5, 6, 7, 8 roots, and that fits with my even going down, down. So write the function in factor form. F of x equals. So with a -1/2, it's x plus a half, or 2x plus 1 cubed. With a 2, it's x minus 2. With 3, it's x minus 3, and then multiplicity 2 squared. For here, I'm going to put x, it's a -3, so we're going to put plus 3, and then it doesn't really matter sign, so I'm going to put minus 2 squared root of 5i, and x, still plus 3, because that's still a -3, plus 2, I don't know if you can see that, square root of 5i. So the only thing that I would be missing if I didn't do anything else is the fact that the leading coefficient is negative. So I'm just going to put a negative out front. And that is the polynomial that would get me this graph up here. All right.